Hello everyone. So today we are going to learn simple questions of linear DP, which we theoretically understand yesterday that what is DP, when to use, how to use, and all those stuffs. So today we are going to see some linear DP questions which are literally very easy, but to start with. Okay. So before starting with those things, let me tell you some simple things to note. Now, first thing, you always have integer or void or any typecasting and then solve function, and then you will pass here the changing variables and the array and all things which are necessary for you, but the changing variables will define that this is linear dp or 2d dp or knapsack dp or whatever. Okay, so linear dp just has all those questions when you just need to change only your I variable. Okay, so the questions are such that where you need to create only dp of I, so you need to store the ith value answer only in the dp array. That's where you will use linear or 1d dp. Now this has some function code and you will return at the last the dp of I. Now the main confusion where students will face, and even I had that, like what to pass here. I sometimes you are passing n, sometimes you are passing 0. Like for Fibonacci you have seen that we are passing n, but in most of the cases for memoization, in most of the cases for memoization, we will call the solve function with I value as 0. Now, what does this mean? When you pass your I value as 0, it becomes easy for you. Okay. So, whatever you pass here, you can pass n also, but then your base condition changes according to that. So, if you have passed your I as 0, if you have passed your I as 0, then your dp of I means, what does this dp of I means? That answer from I to n. That means you have your end as n fixed, but you have variable I which is initially 0, and then you will start calculating it. Okay, so basically this will start from n and it will come like this. It will come like this. So memoization is basically top to down approach. Okay, it's the top to down approach, and your base condition will depend on n. So it's opposite of what you pass here as your I. Okay, so your base condition will mostly be if I greater than equal to n, then do this. If I greater than or equal to n, then do this. Something like this. So your base condition depends on question, but is mostly depending on n. You have to compare it with n and write your base condition. In most of the cases, I could say 85% of cases will be like this. Okay, so easiest way for memoization is to pass your I as 0. So that means you are calculating first for n, then based on your nth value you are calculating for n minus 1. Based on this you are calculating for n minus 2, and until that you will reach 0, and that finally 0 value you will return. That is the memoization approach. Now there are some exceptions like the Fibonacci. For Fibonacci we passed n only directly because that way we could think it easily. But in most of the cases we will pass 0 in your memoization approach. Now for your tabulation approach, which is bottom up approach, so you'll start from bottom and you will go up. So you will start from 0. Here you have start from n. Okay, you'll start from 0. So you have dp of n, and you will initialize 0 and 1 values maybe. Okay, so these are the base conditions which you are initially initializing those values. So these are your base conditions. So your base conditions are depending on 0th and ith 1 value, and then you'll calculate I based on I minus 1 and I minus 2 or something, means you'll calculate I on previous values. On the memoization, you will calculate I value based on the next values which are available, because you have base condition related to n, so you know the answer of n, and then you will calculate the previous ones. Here you know the answer of 0 and 1. Okay, and then you'll calculate based on that to your next values. So your next value will be calculated on previous values, and your answer will be dp of n here. Okay, there your answer was solve of 0, means basically dp of 0. I hope you got both this. Now there are some exceptions where you need to alter this based on the question, based on the thinking power, based on the easiest method you could apply. But in 85 to 90% cases, this is the only approach people follow, and it's easy. Okay, so never confuse like why in tabulation we are returning this dp of n and why in memoization we are doing solve of 0, because there are multiple ways. Okay, there are both the memoization and tabulation approach to solve each question. Okay, mostly we'll follow the memoization, but wherein we will think that there is some space optimization with tabulation, your interviewer may ask you that please go with the optimized approach, then you could go with the tabulation, and under that you can do space optimizations. I hope this is clear. Memoization, tabulation, where to put what should be a base condition, and what to pass when calling the function. Clear? Okay, cool. Now, now we could start with the simpler questions. We'll do two questions. One is minimum climbing stairs, and another is house robbers. Now there are some modifications of both of these questions which I will put in the description, and you can solve it your way. Okay. Now, another thing which I wanted to confirm is mostly DP questions asks you to find three things, like either minimum of, so the question itself says that minimum of all possible ways. You need to return minimum of all possible ways. So DP questions will be mostly available on possible ways. Okay. Like, okay, from this particular point, you can go here, here, here. Okay. And from again this, you can go here, here, here. So minimum of all this you need to return, or maximum of all possible ways. Okay. Or total possible ways. So you need to add there. Here you need to do minimization, maximization, but here you need to do the summation. Okay. Fine. Okay, then without wasting time, let's solve our first question, which is related to house robber. Okay, so the question says that you are given an integer array cost, which is given in the question, where cost of I is the cost of ith step on a staircase. Now, once you pay the cost, you can either climb one or two steps from that particular point. So, if you are at I, you can either go to I plus 1 or to I plus 2. You can either start from the step with index 0 or step with index 1. So you could start from any of this. You could start from step of index 0. You could start from step of index 1 also. You need to return the minimum cost to reach the top of the floor. You need to return the minimum cost to reach the top of the floor. That is the nth step. You need to find the minimum cost to reach the nth step. Now, let me just give you a simple array which is given over here. So the cost array says, let's say this is 10, 15 and 20. Okay. Now you could start from 10. You could pay the cost of 10 and you could reach here. And you could start from 15. You can pay the cost of 15 and you can go here. Okay. So the answer is that what is the minimum cost to climb the stair? You can start at any of these things. You can start at index 1. So pay 15 and climb 2 steps to reach the top. So to reach the top, it's not the n minus 1th index, it's the nth index. So with the 10, you can reach only 20. Then you need to add your 20 rupees and then you can go one step ahead, which is your nth step. So this is 0th, 1, 2, and third step is here. So this is the top of the floor, which is not given. Okay. This is one of the way, or you could start from index 1 and you could directly go two steps ahead and you could reach the top. So this is 15. So minimum of 15 and 30, which is 15 that you need to do. Okay, now what could be the simple thing we could do? Now here we will pass, let's say solve of 0 we have passed, okay, and our cost array. Fine. Now this is I over. So dp of I means what? Now we have initialized that we will need 1 ddp. There is only single array involved in this and we need only I value which is changing. That I value indicates the cost to reach the ith floor. Yes, the cost to reach the ith floor. Okay, so here we have defined both these things. So now you could match that with the steps which we have started in previous video. So step 1 is initialize changing variables, only one. What does that mean? So that means that I is the um, cost to reach the ith floor. So dp of I means cost to reach ith floor. Okay, cost to reach the ith floor. Cool. So now we will, as I have said, that we will go from backwards. So we will assume that that from nth floor to going to nth floor is always 0. Okay, so this is cost to reach ith floor from nth floor. Now that is your proper definition of dp of I, and that's when you can define what to pass and solve, how is your base condition and all. Now just read this question, that cost to reach ith floor from nth floor. We are not starting from below. We are assuming that we are starting from nth floor. Okay, and we have to come down. It's the same cost coming down or going top. Okay, but for solve, it's basically easy to pass 0 and 1. You could pass n also, and that again depends on you. Okay, so the condition would then become cost to reach ith floor from 0th floor. But here I've said this. So now my dp of I says if I is greater than equal to n. That means if I've reached 10th floor or something greater than n, then my cost would be, of course, what? 0. Okay, so that is your base condition which we have defined. Now, of course, the second step is if dp of I not equal to -1, then return dp of I only. And that is the simple thing. Now, recursive method. Now, you could go either one step or two step. So, anyways, I have to go one step or two step. So, what I could do? I could add 1 or I could add 2. So, what I can do is, so let me make two variables. Okay. So, int one step is this cost I, so current value of cost, plus my solve function for I plus 1 and cost. And similarly, my two step will be, I will add this value. So I need to add this cost, and then I have to go for I plus 2 n cost. Now let's say if you have passed n over here, then it should go downwards. Okay, then you should pass I minus 1, I minus 2, and that is hectic. You could not think of it. This you could easily think of it, that okay, I have to add the cost of this and take one step up ahead. Cost of this, take one step ahead. It's not like I'm going to I plus 1 step, I'm going to I plus 2 step. It's like from I plus 1 step, whatever is the I plus 1 steps is there, I'm coming one step down. And similarly for I plus 2. Okay. Now what you have to do? You will store it in dp and return it. So return dp of I is minimum of one step and two step, because you need to find the minimum cost. And so you will store it in the dp and you will return it also. Clear? Okay, so let's just solve the question now. Okay, so what could be our maximum n value here is cost dot length could be 1000. So let me pass this as 1005. Okay, now we will do it as they have said that you can start from either 0 index or 1 index. We will take minimum of both 0 and 1, passing 0 one time, passing 1 one time. Okay, so now this is my int sol, which has int I and vector of int cost. N is cost size. If my I is greater than equal to n, I'll return 0 for sure. Okay, now my recursion steps comes here. So I'll have int one step, which is, okay, first we need to do if it's already stored in dp not equal to -1, then I'll return it. So int one step is, I'll add this cost and I'll do solve for I plus 1. So people used to understand it like I'm paying the cost this and I'm going one step ahead, so I plus 1. But it's actually not like this. But because that is easy to understand, we write the code by passing 0th index. Okay. But actually this dp of I means coming to ith step from the nth step. And that's why we made this condition as if I greater than equal to n is 0. I hope you're clear now. So this is cost of I plus solve of I plus 2 and cost array. And you will return dp of I as minimum of this one step and two step, whatever is the minimum. Okay, now I'll memset my dp array with -1 and I'll return minimum of both of this. So I'll first pass 0th index and 1th index. Cool. So for your understanding of writing code, you can do this, but you should have technically clarity on what you are writing, what your actual DP of I means, because if that could be asked by your interviewer, you should be able to answer that. I hope you are clear with this. Okay, we are done. So now we are going to do another question, which is house robber. Okay, now we could easily solve this question directly. So the question says, you are a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed. The only constraint stopping you from robbing each of them is that adjacent houses have security systems connected, and it will automatically contact the police if two adjacent houses were broken into on the same night. So that means if you are robbing on ith house, you cannot rob on I plus 1th house. You should always go to I plus 2th house only. Okay. So given an integer array nums representing the amount of money each house, return the maximum amount. So this is maximum related question. Previously we solved the minimum related question. You can rob tonight without alerting the police. Okay, so here we can use take not take type of question. Take not take means whether to rob from the ith house or to not. DP always applies on the possible situation, possible ways, as I have said. Okay, so you have possible ways for current house robbing. There also previous question you have possible ways like from I. Do you want to go to I plus 1 or I plus 2? So those are two possible ways. Here, what's your possible way? You didn't have a chance to go to I plus 1 once you robbed ith house. You only have chance to go to I plus 2 only. And as you want maximum money, you cannot skip I plus 2, right? You will, of course, take I plus 2th money. But the constraint here is whether to take ith house, whether to rob ith house or to not. If I'm not robbing ith house, I had chance to rob I plus 1 and that could have maximum money. So the constraints here are, or the ways here are, whether to take or to not take. So this is another kind of question, linear DP questions, where you have possible constraints, possible ways as take not take type of questions. People usually say it as take not take questions. Okay. Again, the same thing. Here my DP of I is what? Amount of money I could rob from, as I'll pass 0 as my solve function, and base condition would be if I have reached something I greater than equal to n, means until n minus 1 it's okay, but if I have reached greater than or equal to n, that means I could not take the money from there. Okay, so that will be 0. So amount of money I could rob from ith house to nth house. Clear? Clear? That's what I'm taking, and that is same as from 0 to ith house. Okay, so this is my DP of I means. Okay, so what is the maximum value we could have is, here is 100. So let me initialize my DP of 105. Okay, now you have solved wherein you will pass I and this is your money. So numbers. N is simply this size. Now if I have reached out of the bound array which is greater than equal to n, that means now I have no house. Okay, so I'll return 0. Of course I could not get any money here. Simply if DP of I is not equal to minus 1, I'll return DP of I. Now you have to take or to not take. Okay. So for take, what you will do? You will take the current value. So you will take the nums I and you will try and go for I plus 1. Oh, sorry, I plus 2. I plus 1 you cannot go. If you have taken the ith uh, nums then. Okay. Or if you are not taking ith money, then you could simply go to I plus 1. Then again you have to decide for I plus 1 whether I should take or not take. You just have decided not to take ith house, not to rob ith house. You didn't decide on I plus 1. That will be the next recursion step. Okay. And you will return maximum of this. So storing in DP and returning it. I hope all the steps which I have mentioned in the previous video will be clear to you with those questions. Okay. Okay. So I'll memset this with the size and I'll try and solve for 0. Okay. So these are the simple linear DP questions. Okay. For the next video, I'll be going to cover some questions which are related to buy and sell stocks. Those are 5 or 6 questions with the same uh, same, I could say, same templates, but then a little changes in each of those questions. Buy and sell stock series I could take next video. Okay. I hope you got the better idea of the DP questions, and your homework will be to try the questions which are given in the description and to write the tabulation approach for all these questions. It's a very easy tabulation approach. Again, there you need to, what you need to do is, so what you can do is, you can put DP of 0. Okay. Or you could consider this as your index 1. Okay, and make DP of 0 as 0. So now your DP of 1 is either to take this one value, or if you have taken the previous value, you will not take this one value. So again, your condition is maximum of either you can take this one value, or what is the cost which you have taken on the previous house, that value. So whatever is the maximum, you will take that. So your answer will lie on nth index at that point. Okay. And you could make the same tabulation of this code also. You start from n and you traverse the reverse loop, whatever is better to you. Okay. So stay tuned for the next video. Do like, share, and subscribe it with your friends. Bye bye.